Temperature monitoring. The temperature monitoring capabilities of a motherboard act as the central nervous system for a computer's thermal health. Deep inside the UEFI firmware, there is a dedicated hardware monitoring section, sometimes labeled as HW monitor, PC health status, or simply cooling, that constantly reads data from microscopic thermal sensors scattered across the circuit board and inside the processor itself. For a hardware technician, understanding how to read and interpret these temperatures is a fundamental troubleshooting skill, especially when diagnosing a system that randomly shuts down or experiences severe performance drops. The critical thermal sensors. When you open the Hardware Monitoring tab in the firmware, you will typically see a dashboard displaying several different temperature readings, usually measured in Celsius. CPU temperature. This is the most important metric. It measures the heat generated directly by the processor cores. At an idle state on the desktop, a healthy processor should sit between 30 degrees C and 45 degrees C. System or motherboard temperature. This sensor measures the ambient heat inside the computer case or the temperature of the motherboard chipset. It helps a technician determine if the intake and exhaust fans we discussed earlier are actually moving enough air through the chassis. VRM temperature. On high-end boards, sensors monitor the voltage regulator modules. These are the components next to the processor that step down power from the power supply. They can get incredibly hot during heavy electrical loads. Thermal throttling and heavy workloads. Monitoring these temperatures becomes absolutely critical when pushing a computer to its limits. If a system is running incredibly intense workloads, such as hosting multiple virtual machines or running local open-source AI models in a home lab, the processor is going to generate a massive amount of heat. If the cooling system cannot dissipate that heat fast enough and the processor approaches its maximum safe operating limit, often around 95 degrees C to 100 degrees C, the motherboard will initiate thermal throttling. The system will intentionally choke the processor, drastically reducing its clock speed and voltage to prevent it from literally melting itself. To the user, the computer will suddenly feel incredibly slow and unresponsive. Automatic shutdown limits and warnings. Beyond just displaying the current temperatures, the UEFI allows a technician to configure automated safety nets. You can set a temperature warning, which will cause the motherboard's tiny internal speaker to beep aggressively if the processor crosses a specific threshold, alerting the user that a fan might have died or that the heatsink is clogged with dust. More importantly, the firmware controls the critical shutdown temperature. If the processor completely overheats, perhaps because the liquid cooling pump failed or the thermal paste has completely dried out, the motherboard will bypass the operating system entirely and instantly cut power to the entire machine to save the silicon from permanent physical destruction. Recognizing these exact symptoms, sudden forced reboots during heavy tasks, is a core troubleshooting objective for any professional managing hardware or preparing for certification exams.